Hello, this is our entry to the competition. We have an application called Nestscope. Nestscope includes Nest Chat and Nest Vision. So Nest Chat, you can use this to chat with the database. So firstly, I'm going to start with an example. Here, this is diversity example. I'll click on it. So whenever you ask a question, it's going to generate an SQL query, and then we use this to search our database. So this is the SQL query generated for the comparison of the species across different colonies. We can see that the Galed Island has the most diverse colony, and at the bottom you can see the table, which includes all the information gotten from the SQL, and you can also download the CSV over here, and you can also see the map. Right here in the map, you can see the exact locations of these colonies, and you can also see the diversity of the colonies. So next prompt we are going to use is how many bird observations were recorded per year. So this is another query that is going to show us a trend, and it's going to show us a graph. So you can see it generated an SQL query. It gives you the yearly trend, and then at the end we can see the CSV, and also this is the trend. We graph the trend, and this is going to be really easy for non-experts if they want to search the database. And then our last prompt for Nest Chat will be how many birds are there in a specific island. So I would say Rabbit Island, and then in a specific year I'll say as of 2021. So we can see it's generating. It's gonna generate a SQL query first of all. This is a SQL query, and then it gives its explanation. And then we can see on the map, we can see it has 16,000 total beds as of 2021. And now we have the data table, which shows the amount of beds as of 2021. So that is Nest Chat. Now I'm going to move over to Nest Vision. So now that we have spoken about Nest Chats, which lets you talk to the database using natural language, we are going to move into Nest Vision. What is Nest Vision? Nest Vision is another part of this project which makes it easier for experts to analyze the high resolution images and spots the birds and the species in the pictures. So here is our user interface. You can either upload your picture, or you can use one of the example pictures we have here. So we have two modes. We have the fast mode and the Sahi mode. The fast mode runs a lot faster. It takes 3 seconds or less, depending on the device you have. If you have a good GPU, it's probably going to take less than a second. But on my system here, I have no GPU. So I'm going to go with the fast mode, and then later I'll show you the Sahi mode. So this is our example. I'll click on it to detect the birds in this picture. And now we can see our stats here. It detected 151 beds, and it took 2.67 seconds for the AI model to count the beds. So here are the boxes it drew around the beds it sees. But as you can see, it's the fast mode, so it just made some errors. So we have this feature that lets the experts correct the AI model, our AI alignment feature. So when you click on this correct AI button, it gives you a link. And then when you open the link, it shows you the image, and then the experts can just click on the birds that the AI missed. So it missed that bird, and this bird, and this one, this, this, and I can see this bird that was missed here. So as you can see, when you click on the birds that were missed, it draws a box. But for this one, it did not draw a box, so we have a drawing tool. You can use that to physically draw around the bird. And now that we'll draw around this one too, because it's did not see that. And this one, because this is the fast mode, it misses a lot of beds. But now I'm going to show you the Sahi mode, which is our faster, which is our more accurate mode, I mean, and it takes a while. We can see here it takes 2.67 seconds for the fast mode. Now let's go to the Sahi mode and see how long it takes. So now that I've shown you the fast mode, we'll move over to the Sahi mode. This Sahi mode is more accurate, but it takes a little more time to run. We're going to use the same image so we can tell the difference. So we start the detection. It's running. Okay, now we have the detection right here. As you can see, draws a box around every bed and it doesn't miss a bed. So it's more accurate, and it detected 117 beds and took 15.56 seconds compared to the fast mode, which took about 3 seconds. And you can see we have a table that shows what the model was thinking in detail, and you can also get it in JSON. So now we have solved the problem of counting the beds. So the next step is to identify what species the beds are. That's why we have this species identification training. We, me and my team are not bed experts, so we need the actual bed experts to help us with this. So now whenever I detect something, it shows you the crop of the bed, and then it's left to the experts to tell the AI model what type of bed it is from the species list. So we can just go with this, and what it does is whenever we tell the AI what type of bed it is, we're going to train a separate model, a classification model, and this way we can be able to count the beds in the image and also identify the species of the beds. That's the next step of the operation. And yeah, that's what we have now. If we had more time, we would solve way more problem, and we can't wait to get to the next step. Our future plans include migrating your database from Access to AWS. This makes it persistent and in the cloud. Also, we are going to solve the problem with erosion. Now we have used computer vision we are almost done with solving the bed counting problem, and we're going to take a lot of stress off the experts because this God does this in so much less time. And the next stuff we want to do is analysis of erosion using computer vision. And yeah, we can't wait to see what happens. Thank you.